Welcome back, geometry students. Today we are starting a new chapter, numero 5, chapter 5. Proofs using congruence. So two different components, proofs as well as like this idea of congruence. So tying a bunch of pieces from what we've learned, especially previously in chapter 4 and 3, together. So section 1 today, it's titled, When Are Figures Congruent? In your targets, what we should be able to do, you can make and justify conclusions about congruent figures, and you can define congruent figures and state their isometry that maps one figure onto the other. Sounds crazy, but we've already done the isometry part. So in order to understand this section, we really have got to look at this word congruent, which in other words is just a description of two figures that are the same size and the same shape. Size and shape. And when you see those two words, shape is often going to refer to the angle measures. Okay, this is what we're looking at when we talk about the angle measures of a figure. Size often refers to then the distance part, or how far it is between two vertices. All right, so the size often refers to the distance. Shape is often referred to as the angle measures. Now, we're going to be working out of our new packet for Chapter 5. So if you have that, great. If you don't, I would highly recommend that you're taking notes on something else. What we're going to be able to do with these congruencies and this congruence is determine the isometry. We didn't talk about this word a whole lot last chapter, but an isometry is nothing more than a transformation. All right, remember our transformations, reflections, rotations, translations, and even these compositions. So it's these transformations. What transformations are happening to allow me to get one figure congruent to the other? And congruent figures will always, if one shape is congruent to the other, it'll always have the same ABCD theorem again. The same angle measure, the same betweenness, the same collinearity, and the same distance between points. All right, so that's angle measure, betweenness, collinearity, and distance. And in case you didn't know, here's the symbol for congruent, right? To show that one shape is congruent to the other. Now, when we look at congruency, we have two different types of congruency. We have something called directly congruent versus oppositely congruent. Directly versus oppositely. Ironically enough, this kind of looks like our orientation from last chapter, if you will. If two objects are directly congruent, that means that point A, if it's here, it's also in the top left over here. All right, or on an older calculator, the equal button is down in the bottom right. It's also down in the bottom right if I rotate it or translate it. Versus oppositely congruent, imagine that some of these have these lines of reflection. Right? We talked about lines of reflection where maybe this one's flipped and translated. The puppy is reflected. The eagle is reflected, meaning if point A is up here, A prime is not up on top of this shape, but it's kind of opposite. It's on the bottom. That's what it means by oppositely congruent, okay? And we're going to look at how to organize that and think about what that means for our different congruency theorems. However, probably the most essential skill in all of this chapter for congruency is understanding what a statement like this truly means, right? This says, all right, let me try and type what it actually says first, and then we'll talk about the most important part. Triangle ABC is congruent to triangle XYZ. That's how we might read it. That's how we might type it. Now, one of the most essential skills is to identify what's happening here without having the image or the diagram present. The order in which the letters are written in the first one relate. They directly relate to the order in which they are written in the second one. Meaning that if I were to draw this triangle ABC and this triangle XYZ, I would clearly be able to say that angle A is congruent to angle X. Because this triangle is congruent to that triangle, and A is in the same position as X, I can say that they're congruent. Angle A congruent to angle X because they're in the same location, first and first. Or I could say that segment CB is congruent to segment. I gotta line them up. Which one's C? That's Z over here. And which one's B? That would be Y. So the order in which these polygons, these shapes and figures are written is essential because it tells us how to line up the different vertices or sides or angles of those two shapes. We're going to talk a lot about that in just a moment. Now, on the first page of this chapter 5 packet, you've got kind of like this diagram, but for yours it's blank. And so let's just talk through it. In geometry, there really are three types of transformations. That's what we did last chapter. There are isometries, which takes one congruent shape and flips it, rotates it to another congruent shape. And then there's shear and size change. We're not too much focused on those, but they exist. We do a little bit with them later on in the year. Now, for the isometries, where I have one congruent shape that turns into another congruent shape, we break them off into those two different congruencies, directly and opposite congruent. Those really come from our transformations that we studied. The two that have direct congruency are translations and rotations. The two that have opposite are reflections and any composition that uses a reflection. Remember, composition meaning we have two things happening all at once. All right, so this direct congruency allows us to see things directly. Opposite congruency means it like flipped in some way, and we have to make sure we lined them up accordingly. So there's an example on that page 1 that we're going to do real quick here together before we're done. All right, so in those 4 problems, use the figure at the right. All right, use this figure in which quadrilateral CDEO, C to D to E to O, that quadrilateral is the image of quadrilateral FABO. Let me outline that one in red. F to A to B to O, right? So that order, F to A to B to O, is a rotation of 180 degrees. 180 degrees. So in a sense, this rotated 180 degrees that way. Could have gone the other way, counterclockwise as well, but it's rotating it, okay? So what we're trying to look at then is to be able to answer these questions. Question number 1, triangle B to C to O. B to C to O. Let's outline that one maybe in green here. B to C to O. Notice that's not part of either quadrilateral, right? B to C to O. However, BO is part of which one up here? EO, right? It is part of BO. So I can kind of use this information. Which one? So we're going to look at these different points, right? B in the red one relates to which point in CDEO? Well, B relates to E. So I'm going to use the E. C in the blue one, right? C in the blue one, and maybe if let me underline or put a square around this being the blue, And then let's just put a half square or something here. This is the red one, so that we can compare them, right? So now, again, we're looking at B to C to O. B was part of the red, and if I rotated it, that lined up with E. I know that because of the way they're written. I also know that C, which is part of the blue, right? C is part of the blue, lines up with F in the red one, right? So that would be F. And O is part of both of them, and that's actually the point of rotation. So it's going to be the same point for that triangle. So we can say that triangle BCO is congruent to triangle EFO, all based upon kind of where they're located and how they line up in the order in which they're written. Now, we should also be able to name 6 pairs of congruent segments, right? Segment AF. Segment, and I'm gonna draw this over here. Just have a little bit more room. Segment AF, and this is where we go back to the very first chapter. There's the symbol for segment. Here's the symbol for congruent. AF is the same as which one in the blue one? Well, if I look, AF in the red is the same as DC in the blue, right? Notice how that essential skill in knowing, right, in knowing the way that they're written becomes important. Let's just try one more. What about DE? Segment DE. Which segment is DE congruent to in the red one? Right? Well, DE is middle 2, so it's got to be AB. And again, if I rotated it, that would land there. It's directly. So AB. All right, now you could do the same thing for number 3. Name 3 pairs of angles that are congruent. Again, I don't really need the image anymore because I know if it was rotated, right? The key is that they are images under a rotation, right? If they are rotated, they have these congruency, direct congruency. It says it right there. That means that angle C has to be congruent to angle F. Angle C congruent to angle F. Or that angle E has to be congruent to angle B based upon the way that they're written. All right, and there's many of them that we could write. E to B. Okay, but notice again, the notation becomes very important. Now, hexagon. Okay, there's a hexagon, EOC, BAF. EOC. E to O to C to B to A to F is congruent to what? We just have to match up. E matches up with B. O matches up with O. C matches up with F. B matches up with E. A matches up with D. And F matches up with C. So all I'm doing when I'm doing that is looking at these 2 pairs and the relationship that exists between the blue and the red up here to try and match them up because they need to be in the exact same spot in both quadrilaterals. So that's our start to congruency and congruent figures. If you have questions, I encourage you to make sure that you reach out. Get a few practice problems out of the textbook today, so good luck with those, and until next time, stay safe.